So today we are talking about graphing exponential and logarithmic functions. You guys are going to be able to graph these two different types of functions. Now you have your foldable on exponential functions, so let's start there. Okay, a few basic pieces of information. This is not on your foldable, so this is just something that I want to make sure that we cover before we actually get to your foldable. Okay, this right here is the general expression for an exponential function. A times b to the x minus h plus k. All right. Exponential functions, the variable is in the exponent. Okay. The variable is in the exponent. That's what makes it an exponential function. Okay. This is what an exponential function can look like. Okay. You see it has a y-intercept. It's increasing from left to right. It's kind of flattening out here. Okay. But it continues to go on and on and on forever, which means its domain would be what? Negative infinity to positive infinity. Very good. Now, every exponential function has a horizontal asymptote. I'll say that again. Every exponential function has a horizontal asymptote. We talked about asymptotes before with rational functions, right? They're lines that we never, what? Touch or cross. Your most basic general exponential function has a horizontal asymptote at y equals 0. Okay?
Every time.
Your most basic exponential function. Now, do realize that if the graph gets shifted up or down, that horizontal asymptote is going to change. Okay? But because of that horizontal asymptote, that means our range is restricted. Okay? So we'll take a look at this graph. If the horizontal asymptote is at y equals 0, then the range would be what?
Zero to.
Because it's an unknown number.
It is an unknown number for, every exponential function. But I'm just talking about for this basic one in general. What'd you say, Thomas? 0 to infinity. We know the infinity is not included, but what about the 0? Do I put a bracket or a parenthesis around 0? Parenthesis. Because it's not defined. If it's a horizontal asymptote at y equals 0, it can never cross or touch it, which means it will never be a part of the range. Does everybody understand that?
So it may be like 0.1 or something, or 0.15.
That could be a value on your actual curve, yes. And the y-intercept, we can see is what? 0, 1. Okay? These are some basic pieces of information for your most basic exponential graph, such as so. These are the types of functions like y equals 2 to the x, y equals 4 to the x, y equals 1/3 to the x. This information applies to all those types of functions. Okay? A base raised to the variable x. Any questions about that? Now, you've seen A, H, and K before. You have seen this before. Where have you seen A, H, and K before?
On foldable.
Yes, on what type of foldable? No.
I remember that lesson.
Let's go back and let's look. Go back and look. You have seen those exact same variables applied to another function that we've talked about.
Isn't it one of them like rational expression things?
We were graphing particular types of functions. It was quadratics. Go look in your quadratics unit, which is unit 4. Well, considering that they have titles.
Okay.
Okay. And go to, it was like our second unit in quadratics. It was our second lesson in quadratics. It said vertex form. It was yellow. Flip open that top tab. That same A, H, and K, that the effects that they had on the quadratic function, are going to have the same effect on this exponential function, okay?
What is the few debts? D-E-T-S. Is that supposed to be dots?
Deets, like details.
Oh.
Jesus. I haven't said details. Okay. Flip over one more. Flip over one more page. Go to translating quadratic functions, stretching, compressing, and reflecting. It's the next page over. Neon green foldable and the ivory color foldable. Okay? Right on this foldable, it told you what K and H did to the quadratic. What did K do to the quadratic? It moved it how? Vertically, so that means up or down. So K did that to the quadratic. K is going to do the exact same thing to the exponential function. Okay, it's going to either move it up or down. What did the H do? It made it go left or right. And remember with quadratics, it was like backwards. Yep. If it was a plus H, it meant it moved which way? To the left. And if it was a minus H, it meant it moved to the very good. And then what did the A do? Stretched or condensed, okay? So this is going to either stretch it or shrink it or compress it, okay? So all of these still stay the same. The same effect they had on quadratics are the same effects that they have on exponential functions. The same effect that they have on exponential functions. Okay, so let's take a look at a few examples. Open up that foldable, the first two, okay? We're going to look at the effects of A on the graph, but we've already talked about it. What is A going to do to this function? It's going to stretch it or condense it, okay? The A can also cause your graph to flip over the x-axis. And if it flips over the x-axis, that means it's going to look like this, okay? So the A can either stretch it, it can either condense it, or it can make it flip over the x-axis. Those are the different effects of A, okay? And the easiest way to graph an exponential function is to make a table, okay? Unlike quadratics, when we were able to find, okay, what was the vertex when we went up 1, over 1, up 3 over 1, up 5 over 1, there's no pattern like that for an exponential function, okay? So the easiest way to do this is to make a table and to do the math, all right? So we are going to plug in -1 for x and apply order of operations. What's going to go first in order of operations? The exponent, 2 to the power of -1. 2 to the -1 does what? It makes it not a positive, a fraction. Negatives flip that number, so it turns into 1 over 2. So you basically have 2 times 1 over 2, and what does that become? 1. Half of 2 is 1. So -1, 1 is a point that's on the graph of 2 times 2 to the x. Let's plug in 0. Do my exponent first. What's 2 to the 0 power? 1. What's 2 times 1? 2. That's another point on this graph. Let's plug in 1. What's 2 to the first power? 2. What's 2 times 2? 4. And let's apply the last one. What's 2 squared? 2 times 4 is 8. So these are all the points that are going to be on the graph of 2 times 2 to the x. What's already on your graph is basically what's considered the parent function, okay? The most basic graph before you ever transform it. So we're going to have -1, 1, 0, 2, 1, 4, 2, 8. So it's going to go up like so. And remember, every exponential graph has what? A horizontal asymptote, which starts where? Where's the horizontal asymptote going to be? At 0. Now, did we move this graph up or down at all? It stayed the exact same. So that means that when we graph the rest of this, it's going to get really close to that horizontal asymptote, but never cross or touch it. And there's your exponential function. It has been stretched by a factor of 2. So if A is positive, it's been stretched by a factor of 2, or whatever that number is. Questions? So all we're doing is we're plugging in X values and trying to find the corresponding Y values. Here's the next one. Okay? Let's plug them in. So I have -2 times 2 to the negative first power. We already know that 2 to the -1 turns it into what? 1/2. So this is -2 times 1/2. What's -2 times 1/2? -1. No need for a calculator. Well, it's just what's half of -2. Let's plug in 0. Side by side. Yep, side by side. What's 2 to the 0 power? 1. What's -2 times 1? All I'm doing is plugging in the X coordinates and doing order of operations to get my corresponding Y's. Here's my next one. What's 2 to the first power? What's -2 times 2? -4. And the last one, what's 2 squared? What's -2 times 4? So these are our points. Now, a -A does have an effect on the graph, and you'll see it once we start plotting these points. What happened to it? It flipped over the x-axis. So a negative value is going to cause it to flip over the x-axis. Okay? To flip over the x-axis, which means that, does the horizontal asymptote change? No. Again, the only thing that's going to change the horizontal asymptote is a vertical shift up or down. So that means that when we graph this function, we're going to get really close to the horizontal asymptote but never cross or touch, and it's basically going to be a mirror on the opposite side of the original function. Questions? What would be the range of this function? Remember, range is the y's. What's the lowest this graph goes? And what's the highest the red graph goes? To 0. Exactly. Lowest to highest. We know a parentheses around -infinity. What's around the 0? Parenthesis. Okay. We're going to talk about each one, the effect that A, H, and K have on the exponential function. Questions on what A does? Let's look at H. We kind of already should have an idea of what H does to the graph. We talked about it on the details page.
Left or right?
Is it down 4 or is it right 4? It's right. And you'll know the difference between which one is left and right versus up or down. It's because that -4, that -4 is in the exponent with the variable. Okay? So, let's plug in. What's 4 minus 4? Say again? 0? Are you sure? Okay. What about the rest of the class? Okay. So what's 2 to the 0 power? What's 1 times 1? So there's a point there. Again, question. Remember, the easiest way to graph an exponential function is to make a table. So when you're going to be doing your homework, you're going to be picking values for x and plugging them in. Okay? And you want to, if you're getting like outrageously large numbers that don't fit your graph, then you might want to like consider maybe smaller numbers or bigger numbers depending. What's 5 minus 4? 2 to the first power is? 2 times 1 is 2. All I'm doing is I'm taking the values and I'm plugging them in. Can you guys finish this off for me, please? You're plugging in 6 for x and 7 for x to get the corresponding y values. What's 6 minus 4? So this becomes 1 times 2 squared. What's 2 squared times 1? 4. And then down here, 7 minus 4 is, what's 2 to the third power times 1? 8. So then these are the points that we're plotting. 4, 1, 5, 2, 6, 4, and 7, 8. And as you can see, just from these 4 points alone, this graph has shifted over to the right 4 units. Okay? What's our horizontal asymptote here? And it's what equals 0? Y equals 0. Okay? So that means that when we draw the rest, we're going to get very close to that horizontal asymptote, but never cross or touch. Okay? I want you guys to do this one on your own, complete the table. And after you complete the table and graph it, I want you guys to tell me what is the range of this function. Okay? So you're going to complete the table, graph it, and then also write what the range of this function is. So for this one, when you plugged in the values of x into the function, you would have had 1 times 2 raised to the negative 3 plus 3. That became 1 times 2 to the 0 power, which just equals 1. Remember, anything to the 0 power is 1. And then you already had a 1 on the outside, so you just multiplied. When you did negative 2, that became what? What was the exponent? 1. So then my y coordinate was 2. So right now I'm at negative 3, 1, negative 2, 2. When I plug in negative 1, what was my corresponding y value? 4. My exponent was indeed, though, a 2. And then, so it's like negative 1, 4. When I plug in 0, you had 3 for the exponent, and it became 8. Okay? What was the range of this function? 0 to infinity. Remember, it will always be 0 to infinity unless the graph has been moved or down or up. So it's still approaching the x-axis, but never crossing or touching. So far, are there any questions? Does everyone see how this graph was moved to the left 3 units? Yes? Okay. Last one's the effects of K. Remember K, do you see the difference between H and K, like the types of problems? The K is big, like the same size as the base. So you already know that that will be the value of K. And remember, K does what to the graph? It moves it how?
Up or down.
Up or down, which means the range is going to change and the horizontal asymptote is going to change because you've moved the graph up or down. Okay? So let's plug in some values. Order of operations says to do the exponent first. What's 2 to the negative first power? 1/2. 1/2 times 1 is? So I have 1/2 plus 2. What's 1/2 plus 2? 2 and 1/2 or 2.5? Let's plug in 0. Anything to the 0 power is? So this becomes 1 times 1, which is 1, plus 2, which is 3. What's 2 to the first power? Times 1. So then I add 2, which is 4. What's 2 squared? Times 1. Plus 2 is 6. So these are the points. -1, 2.5, 0, 3, 1, 4, 2, 6. This graph got shifted up 2 units, which means the horizontal asymptote is now where? Be more specific. Y equals 2, which means I'm not going to draw the curve all the way down to the x-axis because, again, it got shifted up 2. That means everything gets shifted. Not just the graph, but the horizontal asymptote as well. It did not. If we had plugged in 3, we would have gotten the point that's right above it. So it didn't shrink. It just got shifted.
So because the lowest point doesn't fall in line with the lowest point, it changes the y-intercept.
It changes the y-intercept. Yeah, as well, and it also changes its range. What is the range of this function now? -2 to infinity. Is the 2 included? Because it's not defined there. There's an asymptote there. So just like how 0 was not defined for all the ones that didn't move up or down, 2 is not going to be defined either. Can you guys do the last one? Okay. I want you guys to do the last one. Complete the table and also find my horizontal asymptote and my range. Okay? Do it all. Complete the table, graph, find my horizontal asymptote and my range. So with this particular problem, did it move up or down? Down. It moved down. That's effects of a negative K. How many? 3. And if it moved down 3, that means the horizontal asymptote and the range were affected. What's the horizontal asymptote?
Y equals -3.
Y equals -3. And what's the range? With what around? Very good. So that means when you plugged in 0, you would have gotten 1 minus 3, which was a -2. When you plugged in 1, you would have got 2 minus 3, which was a. When you plugged in 2, you got 4 minus 3, which was. And then when you plugged in 3, you got 8 minus 3, which was 5. So then your graph should look like so.